Good day everyone. I will be discussing the electric potential due to continuous charge distributions. My name is Iria Copperly. Without further ado, let's begin. So the objective of this lesson is to understand the concept of electric potential and its relationship to electric field, use appropriate mathematical tools and techniques to solve problems including integration and differentiation, appreciate the elegance and power of the mathematical tools used in electrostatic. So what is electric potential? Electric potential, also known as voltage, is a scalar quantity that represents the potential energy per unit charge at a specific point in an electric field. It's analogous to the gravitational potential energy of a mass in a gravitational field, just as a ball held above the ground has a gravitational potential energy. A charged participant placed in an electric field also possesses electric potential energy. Think of it as a measure of the electric pressure at a point. The higher the electric potential, the greater the potential energy stored for a given charge at that point. So what is continuous charge distribution? When the charge is distributed uniformly over a conductor, it is known as a continuous charge distribution. In a continuous charge distribution, the infinite number of charges are closely packed together so that there is no space left between them. As a result, the load distribution is uninterrupted and flows continuously throughout the charging system, unlike the discrete charging system. So this charge distribution is a collection of charge. There are three types of continuous charge distribution systems occur. The first one is linear charge distribution, second is surface, and the third one is volume charge distribution. The linear charge distribution is the charge distributed over a conductor length is known as the linear charge distribution, commonly known as the linear charge density. It is denoted by the symbol lambda. In mathematical terms, we denoted linear charge distribution dq over a length dl as lambda is equal to dq over dl. The unit of the linear charge distribution is coulomb per meter, or C over m. The charge dq is represented over a small length dl. If we need to find a big amount of charge over the entire length L, we need to integrate the above equation. dq is equal to lambda dl. As you can see, this is the equation. Yan. So the next one, or the second type, is the surface charge distribution. If a uniform charge is distributed over a surface, then it is called continuous surface charge distribution. It is also known as surface charge density or charge per unit area, and it is denoted by the symbol or pronoun sigma, O or pronoun sigma. Its unit is R coulombs per square meter, or C over meter squared. This is the equation or the formula. The third one is volume charge distribution. Suppose the charge is distributed uniformly over a space or volume of any metal or even air. In that case, it is known as volume charge distribution or volume charge density, or change per unit volume, charge per unit volume. It is represented by the symbol P or pronounced as rho, and is denoted by coulomb per cube meter, or C over m cube. Mathematically, volume charge distribution is given by P is equal to dq over dv, and that is the formula. So the electric potential due to the continuous charge distribution can be calculated using two different methods. The first method is as follows. If the charge distribution is known, we consider the potential due to a small charge element dq, treating this element as a point charge. As you can see dito sa figure 20.11. From equation 20.11, the electric potential dV at some point P due to the charged element dq. And this is the formula of the electric potential due to continuous charge distribution. And that will be, ito yung susundin natin or gagamitin natin to solve the V or the dV. So the electric potential at a point P due to a continuous charge distribution can be calculated by dividing the charge distribution into elements of charge dq and summing the electric potential contributions over all elements. So where r is the distance from the charged element to point P. To obtain the total potential of point P, we integrate equation 20.18 to include contribution from all elements of the charge distribution because each element is in general a different distance from point P and Ke is constant. We can express V as K, the integral of dq over R. So the second method for calculating the electric potential is used if the electric field is already known from other considerations such as Gauss law. If the charge distribution has sufficient symmetry, we first evaluate E using Gauss law and substitutes the value obtained into equation 20.3 to determine the potential difference dV between any 2 points. We then choose the electric potential V to be 0 at some convenient point. So this is an example. So the figure below shows a thin plastic rod of length. The length is equal to 12.0 cm and uniform positive charge Q is equal to 56.1 Fc, lying on an x-axis with V is equal to 0 at infinity. Find the electric potential at point P1 or P sub 1 on the x-axis at distance 2.50 cm from the rod. So given, the length of the rod is 12.0 equivalent to 0.12 meter and Q is equal to 56.1 Fc equivalent to 56.1 times 10 raised to negative 15 C. The distance is 2.50 cm is equivalent to 0.025 meters. So this is the equation. So ginamit natin yung formula ng electric potential which is V is equal to K, the integral of dq over R. So V is equal to K, the integral of Q over L dx over D plus X is equal to KQ over L, the integral of dx over D plus X is equal to K times Q over L natural logarithm D plus X is equal to KQ over L times the natural logarithm D plus L minus natural logarithm D plus 0 is equal to K times Q over L times the natural logarithm D plus L minus the natural logarithm D. So, ito na siya. KQ over L times natural logarithm D plus L over D. So, substitute natin yung given which is 18.99 times 10.9 nm squared over c squared times 56.1 times 10 raised to negative 1 5 or 15, C overall 0.12 meters times natural logarithm 0.025 meters plus 0.12 meters over 0.025 minutes. And the answer will be V is equal to 0.07588 voltage or 7.39 times 10 raised to negative 3 voltage. And lastly, this is the references that I use.